Learn VRMR. Come to the Spatial XR community.
In this series of tutorials, I will still focus on using the XR Interaction Toolkit for interaction development. We just set up the underlying plugins, and now we will import the XR Interaction Toolkit into the project and configure it. First, go to the Unity menu, select Window, then Package Manager. In this window, choose Unity Registry and search for XR Interaction Toolkit. You'll see it listed here, but the version displayed in my current Unity version is 2.54, which is an older version prior to 3.0. To use the latest version, we can open the official documentation of XR Interaction Toolkit. By searching XR Interaction Toolkit in a search engine, we can find its official documentation. I'll open it here, and you can see that the latest version is 3.06, while Unity shows version 2.5.4. So, the version displayed in Unity is not the latest. We can copy the package name in Unity com.unity.xr.interaction.tolkit, then click the plus button in Package Manager. Select Add Package by Name, and paste the copied package name. Next, fill in the version number below. If you leave the version number empty, the latest version will be imported by default. I'll click Add, and after a short wait, the import is successful. You can go to the In Project section in Package Manager to find the imported XR Interaction Toolkit. Which has been successfully added to the Unity project, and its version is 3.06. Once imported, we can also bring in some official example packages from XR Interaction Toolkit. In Package Manager, click Samples, and import Starter Assets and XR Device Simulator. These two packages are commonly used in development. I'll first import Starter Assets and then XR Device Simulator, which is an XR development simulator. After importing, Unity will automatically pop up the project validation window, showing required environment configuration fixes. We click Fix All, and once the configurations are fixed, XR Interaction Toolkit is successfully imported. The XR Interaction Toolkit offers several example packages for different functionalities. The first package, Starter Assets, includes some common input configurations and a sample scene, which helps you quickly get started with the XR Interaction Toolkit. Other interesting examples, such as Hands Interaction Demo, Gesture Tracking, Spatial Keyboard, Virtual Keyboard, and Vision OS, adapting XRI to Vision OS. After importing, we can open one of the example scenes we just imported to check its effects. The imported example packages are located in the Samples folder under the Assets folder in the project. Inside the XR Interaction Toolkit folder, open the Starter Assets folder, and you'll find the demo scene provided by the official demo. Next, we can connect the headset to the computer and run the example scene in Unity via streaming. Since I am using the Meta Quest 3, I need to configure the Quest streaming. I open Meta's official streaming software, Meta Quest link, go to General and Settings, and set OpenXR runtime to In Use, while also checking the relevant beta testing options. It's important to make sure that the Meta account has developer mode enabled to see these options in QuestLink software. If developer mode is not enabled, you may need to turn it on again, as system updates can sometimes disable this mode. After the setup, click the Unity Play button to view the example scene's effect. At this point, I entered the example scene, and the view I see in Unity's game window is the same view I see in my headset. When we see ourselves in a first-person perspective inside the virtual world built in Unity, it means the environment configuration is successful. Next, I exit the scene and remind everyone that you can go to Project Settings from the Unity menu. Find the input system package and reference the input configuration file here. This configuration file is related to Unity's new input system, which we'll discuss in detail in a separate tutorial later. For now, just know that the input configuration file is used to record device inputs, like how to detect button presses on a controller. The input system is not activated by default and needs to be manually activated to detect the inputs in the configuration file. One way to activate it is by referencing an input configuration file for project-wide actions in the input system package. When we imported the XRI Starter Assets example package, it already provided an input configuration file, which we can reference. We can reference the XRI default input actions configuration file provided by the official documentation. There are a lot of extra things here, which we will introduce separately later. Once referenced, the system will detect inputs recorded in the configuration file during program execution. After clicking the Unity Play button again, Unity will jump to the project validation window, showing a red error. There will also be many error messages in the Unity console. The game window will display a different view compared to what we saw earlier. The view in the game window is static, but the view in the headset is dynamic. Moreover, the view in the game window will rotate and sync with the headset's view. The screen I see in the headset now is similar to a fixed 2D display attached to my head. We can check these errors and find that most of them are related to the input system. Now, let's go back to the input system package. If we don't reference the input configuration file, Unity will not show red errors in the console, and the view in the game window will return to normal, displaying a first-person perspective in Unity's virtual world. Therefore, the problem lies in referencing the input configuration file. The cause is that the input system package version in the current Unity project is too low. By checking project settings under project validation, we can see that when the input configuration file is referenced, the program runs with a red error message indicating that the input system version must be at least 1.110 to use project-wide actions. In the package manager, we can see that the current version of the input system is 1.81, which is lower than the required version. We can take a look at the official documentation for the input system. The latest version is 1.12, while our version is 1.81, which shows a significant difference between the two versions. This might be because our Unity editor version is relatively low, so the built-in version of the input system it includes is also outdated. To resolve this issue, we can update the input system by copying its package name and using the Add Package by Name method to import the latest version. After importing, we can see that the input system version has been updated to 1.112. And the errors in the project validation window disappear, indicating that the environment configuration is complete. Now, with the input configuration file in place, we can run the program again. This time, no errors appear in the Unity console, and the program runs correctly. The use of the new input system will be covered in detail in future tutorials. For now, we've just prepared the environment to ensure that the input system version in the project is at least 1.110. With the SDK import and environment configuration complete, we can now package the sample scene to run on the headset. Click the File menu, choose Build Settings, then click Add Open Scene to add the current scene to the Scene in Build list. Remove the default sample scene. The first scene in this list is the one we'll enter after starting the program. Make sure the build platform is set to Android and that the run device is selected as your headset device. Then click Build and Run to start packaging. After successful packaging, the APK file will be transferred to the headset and automatically run. First, specify a location for the APK file. I created a new folder called Build in the project and named the APK file. After clicking Save, the packaging process starts. Once the packaging is complete, I will transfer the Unity program to the headset for execution. The scene will display virtual left and right-hand controllers, which move and rotate in sync with the real controllers. I can move the character forward, backward, left, or right using the left controller's joystick. Steer using the right controller's joystick. And trigger teleportation by pushing the right joystick forward and releasing it to complete the teleport. The teleportation function allows the player to instantly move to a target point. Now I will teleport to this position. Here we can demonstrate the grab interaction from the XR interaction toolkit. The controller emits a white ray. And when the ray hits an object, pressing the grab button on the controller will pick up the object. The ray is used for long-distance grabbing, while close-range grabbing is done by bringing the controller near the object. Teleporting here, we can demonstrate poke interactions, where you push a button with your hand. Teleporting further, we can show the grabbing feature. When I grab an object from a distance, it attaches to my controller. And the grab point is where the controller contacts the object's surface. Grabbing an object in the center, regardless of the angle, always results in a fixed grab point. Also, when switching between hands to grab the object, the control of the object's grabbing point changes. I can only grab the object with one hand at a time, and the grab point remains fixed. In this case, I can use both hands to grab the object. Now I will teleport to this location. This demonstrates UI interactions in XR. I can use the ray to point at UI elements. Then press the trigger button on the controller to interact with the UI, such as clicking buttons, dragging sliders, selecting options, toggling switches, and dragging UI panels. Finally, teleport to this area to showcase the climbing feature. I can use the controller to grab the stairs and climb up directly. That concludes this tutorial. We've learned how to import OpenXR and the XR Interaction Toolkit, complete environment configuration, and successfully run the official sample scene. Thank you for watching, and stay tuned for the next session.